students, let's discuss the question. In this question, we have to show that the relation R in a set A of point in a plane which is given by the R, which is equals to PQ, such that the distance of point P from the origin is same as the distance of the point Q from the origin, is an equivalent relation. And further show that the set of all the points related to the point P is not equals to 0, 0, is the circle which is passing through P with origin as the center. So basically here we are given the relation R, which is PQ, such that the distance of point P from the origin is same as the distance of point Q from the origin. So this is basically the function which we are given. So here we are considering let origin is O. Let O is the origin here. So basically relation is over PQ, where the distance of point P from the origin is same as the distance of point Q from the origin. So here origin is O. If the distance of point P from the origin, that is represented by PO, is equals to the distance of point Q from the origin, that is equals to QO. So PO is equals to QO. So here our relation from here is that relation is equals to P comma Q, such that PO, or we can say that OP, is equals to OQ. Now we are going to check the equivalence of the relation, starting with the reflexivity of this function. So basically if P comma P belongs to R, then we can say that the function is reflexive. Now the distance of point P from the origin is equals to the distance of point P from the origin. Basically, P is any point on the circle and its distance from the origin is PO. So the distance of the point from the origin will always remains same. So we can say that P comma P belongs to R. Hence we can say that the function, or basically the relation, is reflexive. Now we are going to check the symmetry of this relation. So now we are going to check if the relation is symmetric or not. The condition for the relation to be symmetric is that if P comma Q belongs to R, then Q comma P too belongs to R. So basically the relation is over the distance, that is the distance of point P from the origin is equals to the distance of point Q from the origin. So we can say that OP, that is the distance of point P from the origin, is equals to the distance of point Q from the origin. If OP is equals to OQ, then we can write this as that OQ is equals to OP. So therefore we can say that P comma Q belongs to R and Q comma P also belongs to R. Hence we can say that the relation is symmetric. So this relation is symmetric. Now we are going to check the transitivity, if the relation is transitive or not. The condition for the transitivity is that if P comma Q belongs to R, Q comma S belongs to R, then P comma S also belongs to R. If this condition will satisfy, then we can say that relation is transitive, otherwise it is not. Basically the relation, if P comma Q belongs to R, which means the distance of point P from the origin is equals to the distance of point Q from the origin. This is basically the relation over the function. Now QS belongs to R, which means the distance of point Q from the origin is equals to the distance of point S from the origin. So from here OP is equals to OQ, which is the distance of point from the origin, and OQ is equals to OS. So this implies that OP is equals to OS. Therefore we can say that P comma Q belongs to R, Q comma S belongs to R, and P comma S belongs to R. So we can say that the relation is transitive, and the relation is all the three, that is reflexive, symmetric and transitive. So we can say that this is a equivalent relation. So the relation is equivalent. Now we have to show that the set of all the points related to the point P which is not equals to origin, or basically the point 0, 0, is the critical passing point through the point P with origin as the center. So basically, let's say we are considering this is our circle, this is its origin O, and let's say this is the point P. So we can say that from here, we can say that the set of all points related to P has same distance from the origin. Let's say this is the point P, let's say here is the point, some point R, and let's say here is the some point Q, and all points are related to P, so the distance of all this point from the origin must be equal. So we can say that OP is equals to OQ, which is equals to OR. Now other points who have the same distance from the origin as OP will lie in the circle with origin O and radius, let's say its radius is OP. So we can say that all the points related to the P is the circle with center O and the radius with center O, and let's say the radius OP. So this is the answer to given question. So students, in order to solve this problem, we use the basic concept of ratios and we use the basic concept of relations and functions. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.